We are very lucky to have Professor Nowshad Amin with us today. He's a IEEE EDS distinguished lecturer in Region 10. So normally we don't get to hear from distinguished lecturers that often. It's a privilege that we have Professor Nowshad Amin with us today. So I'll just briefly introduce him for the audience. Dr. Nowshad Amin is currently a professor in the Department of Electrical and Electronic Engineering at American International University, Bangladesh. And he also serves as the Deputy Director for the Dr. Nowshad Amin Institute of Innovation at IEEE. Earlier, he worked in several Malaysian universities for over 18 years. Where he also led the solar energy research in those universities. After completing his higher secondary education from Bangladesh, he received the Japanese Ministry of Education Monobusu Scholarship in 1990 to study electrical engineering in Japan, where he got diploma from the National College of Technology, then BSc from Toyohashi University of Technology, followed by Masters and PhD from Tokyo Institute of Technology in Japan. His area of expertise include renewable energy, solar photovoltaics, energy materials, and solar cell development, as well as applications. Professor Amin is a senior member of IEEE and a distinguished lecturer of the IEEE EDS Society. Apart from teaching, he has been leading numerous government projects and international research collaborations from different agencies. He is actively involved in promoting solar energy research in Southeast Asia. So let's welcome him. I hope that he will make the session interactive too, and feel free to speak in Bangla.
Thank you, Dr. Manu. Assalamu alaikum and very good afternoon. Thank you once again, everyone, the Dhaka University Triple Department for having me here today. In fact, I was telling to one of your sirs that in 1990, in fact, I tried to enroll here. That time it was not Triple Department, it was Applied Physics and Electronics. So it was my dream, in fact, to enter this university at that time. But luck was that I went to Japan to start my bachelor, master's and PhD there. And today I'm here almost after so many years, in fact, in this campus. I came to Dhaka University for some conferences organized by Dr. Atika that time. So a few times I came. Thank you, Dr. Manu and Dr. Junaid and the EDS of Dhaka University Triple Department. So today I try to share on this topic, solar photovoltaic energy, potential R&D, engineering and R&D scopes, because many of you are very new with the experience that I have overseas and of course in-house, that is here also. I try to tell you what to do and what could be much convenient for you to do in your level. So I'm with AIUB, American International University of Bangladesh, since last January, you can say, the last few months in fact. Before I start, it's a protocol that I have to talk about the EDS as a distinguished lecturer. So EDS, you know, the Electronic Devices Society, it's promoting excellence in the field of electronics, electron devices for the benefit of humanity. In fact, I was that time selected as the distinguished lecturer in 2021. So I was one of these 8 distinguished lecturers that time for EDS. This is the central one. So I was that time in University of Dhaka National, which is Malaysian Energy University, and they celebrated very well. So EDS field of interest, you all know that they are working on engineering physics, theory, experimental simulation of electrons and ion devices, etc., etc. Mostly semiconductors, quantum effect materials, and other materials. I think there are membership benefits that you know. There are so many membership benefits, like you can get education, you can know about the publication, networking, awards, etc., etc. So those who are the members, young members, I think you better explore, you can get the benefits. Here I see that IEEE is just one way we are submitting the yearly fees, but we do not get that much benefits because we are not well aware of it. So I better ask you to know about the benefits that you can get from IEEE as well as EDS. And EDS is on social media as well. It's in Facebook, LinkedIn, and Twitter, or the X. So you can get a lot of information. So those who are not the member, we'd like to welcome to join because you can get a lot of benefits. But make sure that you know the benefits and you are well aware of and you avail those benefits. And I think already Dr. Mainu already introduced me, so I'll just skip this one. So I have experience mostly in Malaysia. After graduating from Japanese University up to PhD level, I worked for 3 years almost to Motorola Japan Limited, where I worked on semiconductor processors. So I remember that time that you see nowadays optical fiber modems, right? Those things were 20 years back. It was just new that time. So I was working to develop the VLSI of that. I remember. So I was with the fabrication team as well. So, but my main topic was solar cell until PhD. So after 3 years working in Motorola, I just changed my track. I came to academia, and my that venture started in Malaysia, not in Japan. So I started my career, my academic career in Malaysia, and I stayed there for nearly 18 years of my life. Then it was very enjoyable. In fact, Dr. Junaid was there as one of our researchers once upon a time, but he could not make 1 year contract, only a few months with us. And I was also strategic higher professor and sometimes visiting professor to King Saud University in KSA. So I had different experiences in different places. I was in UK as well as a British Council fellow, apart from being a postdoc fellow in USA. I didn't mention I was in a postdoc fellow in the University of South Florida on the solar cell related research. So pretty much different kind of experience I had at that time, and with that I decided to stay for the time being to Bangladesh. Let's see how time will decide. You may know that nowadays people are talking about the credentials, for example, the SCOPAS index for journals, then ISI list of journals. So this is the most recent, my credential in the SCOPAS based citing list. I have over 492 contributed journals and proceedings, and where the age index is 52 and citations is nearly 9,840. For the SCOPAS, this is for the Web of Science. You can see the H index is 46 and 406 publications I contributed, and the citation is a little bit lower in Web of Science. This is Google. Again, you can see some credentials. But what does it say? In fact, it says that I was involved in so many papers, and those papers were benefiting a lot of audiences, different kind of audiences. So that's what the citation is. But with that, I should not make some kind of chaos that nowadays you know that people are celebrating 1% scientists, 2% scientists, all those things. But better, I tell you, this is just some kind of like statistical values. Okay? It's not more than that. Nobody can measure any scientist, any minds of scientists by any kind of measurement criteria. So I think this is just because if we don't say it, so I may not get the credibility or credentials to speak to you. So for that, I'd like to thank my research group. Still I maintain the research group overseas. So that time, like in Malaysia. So this is pre-COVID era. So I still enjoy the research. So I'd like to acknowledge the research groups that I work with and still am working with, and also collaboration partners from different universities and the Ministry of Education of Malaysia, because that I got huge amount of grant from them in those 18 years of my life in Malaysia. And of course, there are a lot of literatures that I referred in my research work. I got benefited. So all in all, we are a very nice group. We say we are committed to a solar green earth. You'll know why I put this motto, because we are working on solar photovoltaic. So we'd like to make the earth, Mother Earth, back to its original greener vision with the use of solar energy. So today's outline is very simple. I was telling to Dr. Mainu whether I should go deeper into some specific topics, but this time this is the first time. Maybe inshallah next time I'll also give some more talks. specifically on some, for example, some specific type of solar cells or any applications. This time I'm going to show you, I'm going to share the experiences that how versatile it could be, and you can attend, you can avail those as your research topic or research interest. So this will be pretty much introductory talk today. Maybe in the near future I'll be more focused on some specific type of solar cells and ins and outs of that solar cell since the beginning of that solar cell. So first of all, today I'd like to introduce myself, and also I'll introduce some of the things related to solar energy, and you'll learn about the importance of the solar PV as the renewable energy, then R&D potentials, like possibilities that you can avail from now on. Then solar PV in Bangladesh you should know, because we are living in Bangladesh, we cannot do something with our limited so-called like availability or environment. We want to do so many things, but our Bangladeshi, like the perspective is not rich in that sense. It could not provide us that much facilities. So we have to tune ourselves into whatever we have. Okay, so we cannot, like, we want to make some, for example, we want to make some exotic materials for solar cell application, but in Bangladesh maybe we do not have that facility to grow or to research on it. So I'll be giving those perspectives as well, and finally how we can make ourselves ready and conclude. So those who are very new today, because this talk is a public talk, so I have to start with the very newcomers. So we have to understand why we are turning ourselves towards renewable energy resources. What happened wrong? Because we just, in fact, honestly speaking, the fossil fuel usage didn't take that much time, only 150 years or 200 years. Before that, we didn't know how to use the fossil fuels like coal, oil, and gas. We discovered those things nearly 200 years ago, but now we are towards the extinct of those things, right? So why it happened? So that's why. And also we have to know how long we have those resources gifted by God Almighty. So first of all, you know that crude oil, it has maybe the reserves is only 40 years. The gas, natural gas, maybe 160 years. Coal, maybe another 80 years. Okay, the way that we are exploiting them, so give us the deadline of their extinction this way. So this is one of the main reasons that we have to turn ourselves towards the alternatives. What are the alternatives? So also I would like to mention what are the disadvantages of the fossil fuel based resources that we have been using since 150 years ago. So it is producing greenhouse gas. We all know that. It's creating huge air pollution, water pollution, land destruction, radioactive waste if we use the nuclear based energy resources. And also those resources are very limited or finite. They are not infinite. So we, as I mentioned, that those three kinds of fossil fuel resources are very much limited by their timeline. And also the energy wars. Let's not forget the wars that is happening around us. Most of them are not related to the peace. Honestly speaking, they are related to the domination of oil fields, gas fields, or those networks. Okay, we don't speak about it, but it is the truth. That nobody does any war in a place there is no resource, honestly speaking. This is the trend. So what is the potential refuge? We can say that the situation that we are facing now, the dire situation that we are facing now, is in one hand we are destroying our nature and we are quite near to the extinction of the resources. So what could be done? So luckily, some of the great minds, they found that we can harness the energy from the natural resources that is infinite. So we have renewable energy resources like wind, solar, and wave, tide, all those things, because they are local. They are local, very much locally available. Then they are environmentally benign. Like for example, if the windmill rotates, there is no greenhouse gas emission from these kind of things. Even if we have a dam, although there are controversy about the dam-based or hydroelectric power plants that it changes the ecosystem, but at least it doesn't pollute nearby the environment. And also the solar, the renewable energy sources like solar photovoltaics and solar thermal, they are not destroying anything. Okay? So they are, and as well as they are inexhaustible. As long as there is some nature, like for example the sun, then we can get all these resources for free. So that's why lots of countries around the world are they are convinced by the renewable energy resources and they are adopting it spontaneously. You can see a lot of news here, like the world's first fully solar powered airport in India. Then people are just converting their barren lands into solar field, their golf course into solar field, their airfield is airport into solar photovoltaic generation systems. So you'll see a lot of enthusiastic news around the world. So I should say from this, so from the recent year, we found that over 25% of global final energy and over 30% of the electricity, the two statistical values, are from renewable energy resources. It is a huge, I should say, achievement for mankind. So among the renewables, we have three main streams, like for example, wind, solar photovoltaics, and solar thermal. So these are the main three mainstream, the renewable energy resources, but my talk will be mostly on the solar PV today. Why solar? Because solar, we know that most of the countries, this is the solar map of the whole world, where you can see that most of the countries where people are living are getting from 1 to 7 kilowatt hour per meter square per day as a incoming resource, incoming sunlight. And also there are some of the statistics that says that just whatever we need in a year as energy, the solar energy can provide 10,000 times. Okay? And also in 1 hour sunshine, we can mitigate whatever needs we have. So these are the two catchphrases that we always promote, that why solar. So how to harness the solar energy? So there's a device called solar photovoltaic cell. Almost 150 years ago, French physicist Edmond Becquerel discovered the solar photovoltaic effect, where he found that whenever he put some kind of electrolyte system with some silver rod inside some electrolyte and near the window, and whenever sunlight struck there, and he found some kind of voltage. So that is the beginning of the story. But it is just maybe around 70 years ago, when Bell Lab scientists, they made solar cells happen, and then solar cells are attributed to that. That's why solar cells we call attributed to that solar photovoltaic effect, and which converts sunlight directly into electricity using some of the electronic materials called semiconductors, and that can be configured in many different versions or configurations, like rigid, semi-flexible, flexible, semi-transparent, fully transparent, etc. So this is the chronicle of solar cell. That means the beginning of the solar cell, when the three scientists in Bell Lab, they invented the first p-n junction based. This is the device here. So whenever they discovered this, that time it was 6% efficient solar cell. That means 100% light comes, and only 6% electricity is getting out from this device. So it was that time it was a breakthrough of that time. In fact, that's what the New York Times, they made the article. They said vast power is tapped by the battery using sand ingredient. They put that way. This solar cell, even after 70 years, almost 60 years, in 2002, whenever they measured the efficiency, still they found from 6% the deterioration happened around 75%. It was showing 1.5% efficiency, even after 50 or 60 years. So that proves the durability of this kind of devices. And after that, in the 1950s, people NASA started using the solar cell in their satellites. So this is the first satellite, Vanguard 1, which NASA says they can still get the ping from them, the satellites, so they can hear some kind of ping message. Still it is there, it is somewhere, but still it is surviving. So PV terminologies, those who are new, that starts from the solar cell. It comes because solar cell is a very small battery, so it does not provide us the huge amount of power we needed. So we have to integrate into different configurations by making them in series and parallel connection. We make panels, which is robust in the harsh environment. Then we call it panel or module. From the panel or module, when we put in series, we call it a string, and whenever there are a lot of strings, then we call it array. So these are the pictures how we make the panel from a simple, very flexible or fragile cell, solar cell. Solar cells are very fragile, the first generation one. So we can make aesthetic some kind of installation. for some dome kind of thing, but these are the solar cells. Also you can put on any kind of curve shape, and or we can make a large area like power plant, like this large area solar farm. Solar cells in terms of their generations can be classified into three main generations, like first, second and third. First generations are mainly crystalline silicon based. Crystalline silicon, because that time we are using crystalline silicon for IC manufacturing. So the solar cell community enjoyed the development of IC manufacturing, how to make a p injection, and because solar cell does not need that much high purity, because in the IC you all know that the silicon wafer should be 11N, we call it 11N, 11.9, that is 99.99, altogether 11 nines pure silicon wafer, but in solar cells it needs only 99.999% pure silicon. And it could, by making a p injection, we can make a solar cell. So we have been enjoying the technological advent in the VLSS side in the solar cell. That's why we got solar cells efficiencies up to 26% nowadays in research cell. Then there are multi-crystalline silicon. They are in the second generation, because in first generations are mainly 200 to 500. Nowadays it's nearly to 150 micron thick. So because we don't need that much material, so what we did, we reduced the thickness, but we needed support for those tiny thickness. So 1 micron or 10 micron. So we produce on top of glass, then aluminum foil or like polymer foils. So these are called thin film solar PV, and it is very interesting because there are so many materials. There are only two monotonous materials like monocrystalline silicon and polycrystalline silicon. There are many like combinations. So we can do a lot of research, and my master's and PhD was on this and this. So I studied, and also I studied this in my postdoc. So I'm mainly focused on this because at that time it was almost matured. Then third generation solar cells, maybe around 30 years. This is almost 70 years ago, 50 years ago, 30 years ago, we started this journey. So now the mainstream is perovskite solar cells. Perovskite is a very new material to be used in these PV devices. But also there are also hybrid. There are many quantum device, quantum dot device, then intermediate magnetic semiconductor, multi-junctions. There are many futuristic applications, but those are still in the research stage. So if those who want to do research, they can do this one. Now the evolution in terms of size. I just want to show you, this is the calculator I purchased in 1991, whenever I started my undergraduate study in Japan. So this is a solar cell, and believe me or not, this calculator still works after 32 years, maybe. Okay, it still works. There's no battery in it, and it was in the milliwatt peak range. And today, recently I visited one of my students' company in Bangladesh. He showed me, he imported some solar panels. The size is 670 watt peak. So this is the evolution that happened in the last, maybe I should say, 30 years. Of course, in that case, there was small panels, but not as big as tall as or taller than me. So this is the evolution happened, because everything the technological advent happened so drastic that we are enjoying 20 times cheaper than last 15 years ago. 20 times cheaper, the solar cell price. And commercially available solar cells, mainly first and second generations. First generations is mainly silicon, crystalline silicon, and polycrystalline silicon. But the thin films, like cadmium telluride, amorphous silicon, there are amorphous silicon panels, also CIS panels, copper indium selenide or copper indium sulfide panels. These are commercially available. So the chart, which is developed by NREL, National Renewable Energy Laboratory, this chart starts the record taking from 1976 of different kinds of solar cell configurations. So each color denotes one kind of solar cell and how they evolved in terms of efficiency over the time. We found that the highest efficiency is 47%, which is in fact, which is called, we can call them like this is in fact multi-junction, which is used mainly in the space applications for satellites, all those things. So for terrestrial application or on the Earth application, we use mainly silicon and the thin films, which is the efficiency is around 26-22% here. And there are also low-cost technologies. This is like Dyson-Sita solar cells are polymer based. They are nearly in the 11%, 12% efficiency range. So there are three different kinds: 40s, 20s, 10s in that range. So this is the chart for the convenience. You can see that the concentrator or this is gallium arsenide based. They have 47% efficiency, silicon based 26, thin films 23, and then others to 11, dicells, etc. So where we use, we can use anywhere, everywhere. That's why we call it ubiquitous. Okay? We know that these terms we use for network. So the solar cells can be utilized in the terrain, okay, or whatever texture you have. Then in the desert, train, houses, EV charging stations, yacht, even Mars rovers that we send to other planets, right? Then even planes, okay? Everywhere, anywhere. But it didn't go, I mean, in a day. It started from this story when people used to put very heavy diesel-operated generators on their head, but that reduced to this just hat kind of things. This one. We also changed to Bangladeshi cap. You know the Bangladeshi, the farmers. We have changed to one of those. So it's it says 1,000 words. Like this picture tells us the 1,000 words to support the story. So this is the beginning of the story of usage. Well, like usually we use one panel system for rural electrification, few panel systems for water pumping from ground, then large-scale rooftop solars in some big companies like FedEx and these Sharp LCD factories. So 5 megawatt, maybe 10 to 20 megawatt, etc. If there is any problem in the land, we have agrivoltaics, or sometimes we call it agrovoltaics. There are two names, agri and agro. So we can push or pull that towards a little bit higher elevation panels, then we can use the land beneath it. We can grow produces or even corns, paddy, etc. This is agrovoltaics in Bangladesh. This is an unintentional example from Mitakugur by Renewable Solar. They, in a paddy field, they put some solar panels and they found that beneath it, due to the diffuse sunlight, still the paddy grows the same way. Okay, so this is one of the example in Bangladesh for agrovoltaic. But very recently, floating voltaics, floating PV photovoltaics. In Singapore, because Singapore they have maybe just only one reservoir, sweetwater reservoir, they try to cover it. So how they covered? They covered the solar panels. So they are using solar panels and they are reducing the evaporation by that way, as well as they are getting power from this kind of lake. And there are also some estuary and very near to the sea, etc. So you see now floating PV is also emerging nowadays as usage. But is it possible to have a nuclear scale power plant? I always do some argument for the Lupur nuclear power plants in our country. I always said there is no need for it, apart from the corruption story. I said, we don't need it in fact. Why? Because our neighboring countries have nuclear scale power plant based on solar. So once upon a time it was a story that whether it was like challenge whether we can have the nuclear equivalent solar plant. Yes, our neighboring country India in Rajasthan they have in 47 square kilometer area 2.245 exactly our nuclear reactor scale. Okay, two of the reactors. We have two reactors, 1.2, 1.2. I mean, it's like 2.2. So they have in the 5 kilometer times 10 kilometer or 11 kilometer. So in that area they got around 2.245 gigawatt or 2,245 megawatt, and it is producing in a day for free 10 gigawatt hour a day, and the cost is per kilowatt hour cost is only 3.2 US cent. So it is a huge. Of course, they are getting their radiation is 5.72. Our radiation is 4.5. Around that, we have less radiation insolation from the sun, but at least we can get maybe 8 gigawatt hour if we have this kind of installations. So it is so we can put forward to compare the nuclear scale power plant or nuclear based power plants that no solar can do. And in fact, in many countries they are now doing in gigawatt range. This is 2 gigawatt. India, in China, they have 2,200 megawatt. That is 2.2 gigawatt. It is another nuclear scale. In India, another one. It is 2 gigawatt. Okay, it's in Pravgada solar park in Karnataka. Yes, they have also nuclear scale. 2 nuclear reactor equivalent solar power plant, and the price is very low, only 2.1 billion. Total installation cost is $2.1 billion. It's nothing. We are putting what our towers. 12 billion, right? 12 billion, which was, yes. So the global solar energy scenario, I just took it from our work in data. So the most recent data says by the year 2023 we got over 1400 gigawatt of solar installation. Means if we didn't have the solar technology, that means we needed 1400 nuclear power stations, nuclear reactors, if we didn't have solar. So we can say that nuclear, this much nuclear reactors are replaced by solar energy. And how much the energy was produced? So this is the energy production from different renewable energies. So mostly hydropower, then wind, then solar. So how much solar produced in 2023? Solar PV produced over 1,629 terawatt hour from 1,418 gigawatt peak of capacity. Then if we compare the LCOE, levelized cost of energy of solar, if you compare, there is biomass, geothermal, hydro, solar, concentrated PV, offshore wind. So we see that solar from the 2017, it is quite neck and neck. It is very comparable with other offshoots. So IEEE, International Energy Agency, declared that electricity from the solar is the cheapest in many countries of the world. They declared in 2020. So this is a very good indication. Then the projection by the 2050, what will happen? We found that everything may be pretty much declining or same rate, but renewables will increase and solar, so does the solar PV. Now my talk is towards you, the novices here. Okay, so what kind of scopes are waiting for us in this field? Okay, I'm just it's the engineering job scopes. First of all, engineering job scopes. Those who want to engineer, who don't want to proceed for further as a research or something, for them what could be the options. So here, first of all, you have to know the solar we use as our power generating resources. For example, we have systems like stand-on system, which is with a battery, and there are hybrid systems with some diesel generator, we call it genset, and PV array, and also grid connected systems which do not have any battery. So these kind of systems are for small scale, like 5 kilowatt, 10 kilowatt. So you have to know, I always give this lecture to our students, that whenever we put solar panels on our rooftop, solar panels is the heart, it's resembling our heart of a human body. Charge controller is the brain, there is a controller to stabilize the charges. Then batteries are the stomach, okay? So what I say, to have the perfect body movement, I need the perfect synchronization of these, and these. For example, my stomach is full, my heart is okay, but my brain is not functioning well, so you may not get any kind of benefit from this body, right? So that's why we must know that how to do, this is called sizing, photovoltaic system sizing. Many of you in Bangladesh, I see that people do not know, they just put this and that without calculation and they do not get the right benefit from any solar systems. Most of the systems fail. You can see after 2-3 years they fail, but these panels are for 25 years. Next, to understand that PV system sizing or PV system design, this is a science and art both. The science is related to all scientific things, and art is how you minimize the cost, how you maximize the benefit. So you need to know some steps. In Bangladesh, I think, I'm not sure about your curriculum. Nobody teaches in that sense. No, I think even in workshop, nobody talks about it. So they just happen to be the system integrator or something like that, or they just follow some kind of a manual from somewhere. So we are not getting any benefit from that sense. So we must understand some steps. Today, maybe due to the time constraint, I'll just go through, but maybe next time I can give you a 6 hours lecture for both grid connected and stand-on system, like optimization of sizing. So there are engineering job scope here. Then grid connected systems. Grid connected systems do not need any battery. Again, there are a lot of job opportunity for PV installation, grid connected system, because in the grid connected system there are different systems for different schemes. FIT scheme, NEM scheme, then CELCO scheme. There are different kinds of schemes. These are all the policies from different countries. More or less, in Bangladesh also follow the same. But one of the thing is, recently Bangladesh introduced NEM system. Means you put rooftop solar, you do not have any battery, you just sell in the daytime, you buy it back at night time. There are two things, because we have power shortage, so they do not give us back at night time when I need it. This is one problem. The other problem is our meters are all prepaid meters now. So prepaid meter cannot keep track of this energy business or energy flow. So we have to go back to the postpaid meter, or we have to reintroduce new meter. So this is a big problem for us. We don't know how to solve it. So there are lots of engineering scopes. You can see a lot of companies, RMGs, they are putting rooftop solar. I'll show you something there. So for grid connected solar, there are 4 different kinds of things or configurations, different type of configurations. So we have pure electrical things there. You don't have to know the solar cell configurations, like deep into the device physics or material science, but you can do pure engineering if you want, because you are not AAA. So there is engineering job scopes. Grid connected systems can be rooftop, can be on premises, like our university here also can be full. Then kind of pole mounted, maybe on ground mounted with large scale solar. So there are a lot of engineering scopes, or large scale solar farm in barren land, unused land, reclaimed land. Nowadays in Bangladesh we call reclaimed land, where we have the islands, chars that sometimes popped up, right? So there are also engineering scopes. Now the research scopes. Okay? It has versatility. Of course, I believe that you are in one of the most prestigious universities in Asia as well as in Bangladesh. So you will do research. Okay? You will not stop here. You will go further in the masters and PhD. You can be the leaders. Home and abroad. First of all, prospect of PV research. This is very important for all of you. For example, PV research, we can do system research. Okay? Then device research, then materials research. This is what I feel. You may not find this somewhere else. What I felt, I just put it down here. This is according to my own experience. So PV research can be categorized into 3 different kinds. For PV research for system, you can use many softwares. Usually PVSys is used by the professionals. PVSys is a software. 15 years ago it was free. I used to teach my students. Now it is a proprietary one you have to pay. Because most of the largest solar farms are using PVSys, this software. Okay? Then there are Homer, there are PV Sol, there are PV Watts. We teach, in fact I teach in my course in the university that I teach some of them, Homer, PV Watts, not the PVSys, in the limited time. So then device research, this is more interesting. It can be more simulation based or experimentals. You need to have at least some softwares as well as some research establishments. Then the material research is more like I should say advanced. It is on the material science as well as device physics. It's too much too related, this one. So if you do not have anything, you can start with the simulation, first principles calculation like DFT. There are some proprietary softwares like VAST, Quantum Espresso. This is free software, and there are some proprietary software. So you can start thinking of making the PV materials, like using the softwares. This is for the device. Okay, this is for the device research. For simulation, device simulation, I put a list of the available softwares. You can get it. Okay, you can get it for free. For example, aforesaid by this German university. Then there are AMS. We use PVC, PV. Then what? AMS, PVC, PCA, 1D. There are so many. So you can use to study the device physics. Okay. Then now, potential PV research focus. Now I would like to show if someone wants to do on the application side. Oh, I want to make use of PV energy for some of my applications. Now whatever you see, it is my experience. Just to open your eyes. That we have to maybe similar. We can do something. First one, BOSS. We call it BOSS. What is BOSS? Balance of systems. Apart from the PV panel, whatever else is called balance of systems, like controllers, inverters, batteries, the whatever like switches, etc. is called the BOSS, balance of systems. So there are charge controllers, PV inverters, grid-tie inverters. Then when I started my career in Malaysia in academia, so I didn't have a lab in fact. So what I did, I started doing this PCB, like making controllers, and we got, this was at that time Malaysian MOSTI, Minister of Science and Technology Minister. He came because we have so many different kinds of things, and also I commercialized this product almost 12 years, so 2009, commercialized this product. This product is a small panel, we can charge 3 appliances at the same time. So this is the University of Dhaka, National University like Dhaka University. So I bought 2 million ringgit to commercialize my product. So it was very, and also we started doing some community project, like for example, going to some places, how to change their not lifestyle, how to change their energy scenario with the help of renewables. You can do those studies, going to some remote places. So charge controller is one of the BOSS, not BOSS, this is BOS, single S. So this BOSS, this is the controller. I said controller is what? Is the brain. So you can use lots of algorithms, fuzzy logic, generating algorithms, sort of algorithms, to make what? To make an MPPT charge controller, maximum power point charge controller. Okay, you can make and you can do variations. So these are the main whatever is marketly or commercially available. But we also made our own charge controllers. Inverters, yeah, inverters. You can make hybrid inverters. You can make this kind of grid connected inverters. Nowadays, grid connected inverters evolved so much that even if I have a PV system on my rooftop, I can hang using the grid connected inverter to the national grid, because it will not disturb our grid. Previously, it was not allowed. Now, this inverter is so advanced that it will not disturb. There is no harmonics, nothing. You can just simply hang to the national grid and you will get benefit to the NEM, net energy metered system. Next, these are the innovative, I said our innovative solar products, like for example, smart home with some controllers and with some smart plugs. We convert conventional premise or home to a smart home. My old small car with a solar panel, it was changed to semi-solar car. It was taking the solar power for its air conditioning. Okay, then a water purification system, laptop charger. This is the cap. I made DCS for DCSR 1 and myself 1. Still, it is surviving. 2016 or 17, I made it, but still, even after 8 years, it is still surviving this way. It is good for those farmers, those who plow or those who like help the agriculture. They can hear music or whatever, and they can charge their courtyard at night. These are some LED lamps. So this is the first one. I said this is commercialized, and this is a drone, because the drone needs aerodynamic. If you want to integrate solar panels, it needs aerodynamic design. But our drone was very unstable, very lightweight drone. This is a car, flexible solar panels we put, and we got some recognition for this one. And also, this is a easy bike. We can convert. Still, we are working. So some students here how to convert our easy bikes. Or nowadays, Bangladesh has the most penetration of EV, right? Not the Tesla one. All the tricycles, EV. It's also EV. We cannot deny. They are all EV. I think Bangladesh has the most EV penetration in the whole world. You can, if you check, because we always EV, we miss Tesla. It's not Tesla. So all the rickshaws, whatever vehicles now this. So about this, we got recognition in the Shell Eco Marathon. They have a F1 circuit. So our one was the one. Then, but what I said here, after a few years, in 2018 or 19, I went to Japan. I found that Toyota. I went to Toyota Technological University. The professor showed me here. The Toyota is planning. The Japanese system is always there quiet. They don't say first. They say after a few days. They do not say before anything. The culture is different. I was in Japan for 14 years. The culture is completely different. They have 300% data. They just show 80% data. Whereas the other countries, maybe they have 80% data. They show 120% data. This is common trend. Those who have experience in Japanese universities, you may know that. So this is Japan. They are doing research. They found that if they put 800 watt rated solar power, it can run for 30 kilometers a day. It can be used completely on solar. You don't have to plug in or whatever, hybrid, no. Okay? And we did something else, home energy management system. I said, since you are electrical engineering now, you can do the so-called system. Okay? You can make some home energy management system with the solar so that we can reduce the energy cost. So this we have done some research. This is the example. We have some solar panel. So we took control of every appliances with our some kind of intelligent plugs. Okay, smart plug, and we have a controller. So we will see. Time of use. There is a tariff system called time of use, right? Those from electrical time of use. Okay. In some countries they have a slab-based tariff. In Bangladesh we have slab-based. In China, in first world country, they have time of use. For example, from 8 o'clock in the morning until 12 o'clock, tariff is different. From 12 o'clock to 3 o'clock, tariff is different. Electricity price is different. So that way, the price varies. So this is good for them. It's smart home. Then we created, this is up in 2022, there's a part given to me that time in that university. So we have a container house fully powered by the solar panel on rooftop, and it's inside is a lab. So we put like system, 3 kilowatt system here, and all different kinds of panels and controllers. So we have a small, and you can see there is also AC, so it is okay. In this small matrix, at least 3 or 4 students can work. There, this is a small solar cabin in a living laboratory. Then we have shown you the small water purification system. So the bigger concept got NSF grant in 2020. So I made this one, in fact, that time, after this is my delivery. So I got the NSF grant, National Science Foundation grant in 2020, and it prolonged until 2023. So we provided this rainwater into pure drinking water conversion system with the solar energy. These are all like, using the solar, you can do anything. So solar, if you need any power, you can do everything. So this depends on you. If you want to say, I want to make something that will run, that will be self-sufficient in terms of energy usage, then you can choose solar. This is the most popular energy system. Then also we made PV. I said there's a small card. I used a solar panel on that. We have our own meter. So I was running my car and I was taking the data. So there are 2 or 3 batteries on the back. Okay, it was taking. So I found, after running 2 months continuous, I found that my production is more than my consumption. Like my production was 18 kilowatt hour, my consumption was 4. So I can resize my panels. I thought that AC needs more, but car AC might not need that much because it's a direct compression, direct DC compression, not the AC compression. So there's a less loss. So I can resize. I can use just half of the panel. It was 265 watt peak panel. So maybe a 100 watt peak panel will be enough for this kind of conversion for AC, the air conditioning system. You can do also those things. You can try if you have access to those facilities. Now I'll be talking about mostly the solar cells. That time I was talking about the applications. Now, what the research scopes. Starting from this slide, a solar cell needs, first of all, materials. Okay, and in the materials there are many choices, right? Inorganic, organic, bulk, thin film, dye. Materials becomes stack, means device, structure. So homostructure, heterostructure, amine kind of structure, Schottky structure, etc. Then they all need fabrication process. Okay, physical process, chemical process, etc. Okay, these are 3 for the researchers. And finally, you have to make sure that they are economically viable. Okay, so that is what we know. Okay, we need to know. So these 3 things. So why? So you can do only on material science research. You can do on the structure, or you can do fabrication process. So there are huge tasks for you waiting. It's never-ending story. Almost, I started my solar research in the masters in 1996. Yes, 1996. So starting from almost 30 years, it will be maybe another 2 years, it will be 30 years. So we know that we are struggling, we are doing. What is important? You enjoy it. We enjoy it. We really enjoy yes, we have struggles, we have so many ups and downs, we have fund shortage, this and that. But we really know that this is an amazing device that if we face to any kind of light source, it will produce electricity. So when I came to Malaysia, so I was given a very abandoned house in 2007. This is my professor. He was my master's and PhD supervisor. Still, we are in touch. In fact, I know him since 1996. He's one of the renowned scientists in solar PV, and he was the highest ranked scientist in Japan. Okay, he got the blue ribbon from the Japanese Osama, or the emperor. Okay, so he came to encourage me. So this is the lab where Dr. Junaid, Professor Junaid, right, came to as a visiting lecturer, a visiting researcher. So I converted into, now if you enter, here's a video file. So it is possible to convert into any premise into a solar. This is the interest. Believe it or not, every single thing you see here through one of my grants that I applied for, competitive grants. This is a clean room. So inside, this is the equipment that Prof. Junaid was used to start his research, but he came back. So here, we can do the second generation research. Second generation solar cell research does not need that much investment. It's very small. You can do many things. So our Japanese counterparts, many professors now in the Japanese leading universities, they are all not our size, our age. Okay? So these are the Japanese professors from Tsukuba University, Kyushu University, Tohoku University, all those universities. They usually come to Malaysia to have a bilateral workshop things. I'm showing this one. This is the third generation solar cell, especially for the fabrication of perovskite. If we have this kind of chemical lab, we can do perovskite materials research. Those who are well aware of it, it's very simple. Okay, so you can do a lot of research, but this cost is much less on 1/10 of those investment. So we can do this. And then I'll be showing you some, because our research focus was not everything. We cannot cover everything, but we did something on here, something on here, something here, something here, something here. So let me show you some of the research outcomes that may provoke some kind of investigation in you. For example, solar cell is usually we cut into slices the wafers, then we process it, p-n junction, and then we panelize it. We make the panels, and finally we get the solar panels. Okay, so in Malaysia we had a lab where we can produce panels from solar cells. We can process. This was a lab. This was, we call it pilot lab, pilot plan. From here, someone can start his own business. Okay, so but what to do in the research? So my thinking was like that. I thought that the leaves, all the leaves around us are solar cells. In fact, they are the solar cells. They are getting what? They are getting the sunlight as their food. But our solar cells is getting sunlight as electricity. So there is one thing that they have in common. What is that? There is sunlight absorption. Most of the trees or plants, they have only one leaf. But how can they survive with one leaf? Because of their structure. So we started thinking of biomimicry study, like taking the leaves and understand the leaves structure, because these leaves are trying to get most of the sun's energy. Okay, so we studied this leaf structure, and we tried to replicate with our whatever nanotechnology, nanorod, or gratings, or like whatever, like groovings, texturization, all those things. And then we found that our things work, because usually it was this 0.15 ampere, but we can increase up to 0.2 ampere by introducing grid pattern with nanorods. This is the just beginning. If we didn't optimize, so the efficiency value is 8.5%. But at least the same way, the solar cells made, voltage is same, but current changes because of our introduction of new kind of texturization. And also in hybrid solar cells with silicon, with amorphous silicon materials, we did something. We tried to, for example, usually the wafer-based one are 280 micrometer P-type silicon. But we process on the both sides. We introduce, this is the normal structure. Okay, we introduced 5 to 6 nanometer, and we saw that there is improvement of efficiency from 10% to 16%. There is a huge difference. So these are the new thoughts we try to do, but commercialization, it will be done by someone else. We just start the thought-provoking studies. Okay. How to improve. For example, just 2 nano, 5 to 6 nanometer layer on both sides of the wafer because of passivation. If you know silicon, it has a problem with the surface dangling bonds. So we have to passivate the dangling bonds. So then second generation thin films, this was my master's and PhD research. So I was going down to 1 micrometer thick, which is extreme thickness or extreme thinness in terms of thin film, 1 micrometer. So I did that. Then 11.2% efficiency was found. And then after that, what I did is to texturize the surface. So a solar cell is a stack of different materials. So you can study different materials or you can stack together. There are some people, those who study only the materials, they don't do device. But we who are from IEEE, we also do device. That is interesting thing. That we have to consider the surface recombination, surface mismatch, all those things. The lattice mismatch, lattice constant mismatch. You remember those things? So we need. So we do a lot of thin films study, different colors of thin films on top of glass. We study the AFM, we study the different kind of characterization through for the structural properties. For optical properties, we do this kind of characterization for electrical properties. So these are the 3 different kinds of characterization we must know. So make sure that you know all those things. For getting funds or for getting scholarships, you have to write down, I know a PL, I know this. This one is enough to get you to get something, because Prof. Junaid, when I saw his CV, he knew MBE. I think in Bangladesh, maybe he is one and his wife is the other one. who worked on the MBE, because I used MBE. MBE is a molecular beam epitaxy instrument which is very high-end, which is used for gallium arsenide based research like LED, all those things, laser. Okay? This is the 𝐒𝐸𝐴 solar cell, the low-cost solar cells that we can produce by this stack, but efficiency. You can do the interface study between the two layers. Then you can do the flexibility. You can do on top of flexible substrate polymers. Also, my professor now, 2-3 years ago, I visited him again. Whenever I go to, I'm a regular visitor to Tokyo, so we went to visit him, and he's now 76, 75 or 70. Yes, he's going to 75 now. So he showed me that still in this age he's making solar cells, okay, 5 junctions, vertical junctions, amorphous silicon. Okay, then pixel solar cell, because this kind of solar cell will be used on the car body. Pixel, like you don't understand, you will not see the difference. So these are the pixel solar. Each dot is one solar cell. They are connected. So these are the solar cells, and he showed me the rooftop. He's not in Tokyo Institute of Technology anymore, in Tokyo City University. So now I'd like to show you the perovskite one. There are so many different structures. You can study their simulation. You can simulate their theoretical studies, and you can make sure. Also, I think in Bangladesh, some of the chemical labs can do. But what is the problem? We do not have a synchronization. We do not have a group work things or teamwork things. We do not have. We do not enjoy that one here in Bangladesh. So we also need perovskite. Perovskite is very easy because you can do it on spin coater. Spin coater, but you need a globe box. Globe box is a kind of limited control environment. So in our case, we got 18% efficiency. And then what we can do next? We can do for the systems, okay? PV plants, their forecasting. Nowadays, in Bangladesh, we have so many power plants or on rooftop plants. You will see massive. I'll show you the list. How many massive power plants, solar-based power plants are going to be installed by the year 2030? So what do you need? You need to maintain them. It is because Bangladesh now is moving towards from the OPEX model to CAPEX model, right? You know the CAPEX model to OPEX model, operational model of these solar power plants. We do not put commodity. We just buy the. We just don't put the solar panel, pay the price for the panels, but we buy the electricity from solar and we pay accordingly. So I have to put the very best panels, very best systems. I have to ensure that my systems is the best, so that I can give more electricity to the grid and I can be benefited. So some of you can study the prediction modeling of the solar power plants. For example, I have a rooftop system. Tomorrow, how much it will give? One day, after 1 week, how much it will give? You can do it from this kind of parameters. You can do. Okay. We also did. We studied on some simulation software. We studied. Also, integrated related issues. Solar systems, solar panels are for almost 25 years. Okay. But we may have a problem. Contact failure problem, string integrity problem, glass breakage problem.
Correct.
This is okay. I don't think mouse.
Mouse pad.
No. Battery is very good. That means it is not charging. Oh, sorry for the interruption. solar, after making the solar panels, whenever we are selling, there is a timeline for it, like 25 years of like warranty. So within the warranty period, there might be different kind of problems because of the climatic conditions and operating conditions. So what can be done? So we can study those, because every solar panels are measured under the control environment, right? Whatever wattage or whatever VOC, GSC, whatever parameters we get. So what we have to do, every country has their own like kind of microclimate. Okay, so there might be different kinds of problem. Some of the problem may occur in the first year, less than 1 year. Some of the problems may occur in the more than 5 to 25 years, because 25 years is the warranty period. So there are different kinds of problems. We sorted, we found now how to find it before it fails in the field, because once it is failing, the whole system maybe like maybe out of out of work for several hours. So how can we find before something is going to fail? So that is another issue nowadays. So we are studying those, and also end of life, because in Bangladesh we have been using solar panels since 90s. Whenever 1996 maybe, the companies, some of the NGOs like Gramin Shakti and others, they introduced small systems to our villages, and those systems are still working even after some 20-some years. Maybe in near future they need recycling. So you can start thinking of a recycling process. And one of my papers, in fact my students, he wrote the recycling related paper, and it is now highly cited. I feel like very ashamed that his paper, but it's a very glory to me as well. His paper is the highly cited one, because he did something on the recycling of perovskite matrix, which is a new. Nobody has still started its fabrication, but he's thinking of the recycling of perovskite, and he did some experiment in my laboratory. So his paper now is highly cited one. Now the status of PV in Bangladesh, just for your information. What are the sectors in Bangladesh? Bangladesh has over 1378 megawatt of renewable, which is 4.44% of the total energy share in the generation mix. Although we have a capacity, it is said that the capacity of Bangladesh is 31,000 megawatt, but in a day or daily basis we are getting only 12,000 megawatt, less than half. Most of them are not running, and we are paying, the corruption kind of things. So Bangladesh has a huge prospect of solar energy, incoming solar energy. I'm not sure what happened. So the daily average solar in different places over the period of different months, we have different solar installation or radiation, but on an average we are getting 4.5 kilowatt hour per meter square per day. We call it yearly daily average. Okay, and different places are getting a different, but there are huge prospects for Bangladesh. Among the renewable energy resources, 1378, solar has more than 1 gigawatt altogether. More than 1 gigawatt, and a kilowatt peak system can create, if I have 1 kilowatt peak system, so it can create 3.6 to 4.2 kilowatt hour a day. Or in a year, it can produce 1314 to 1534 kilowatt per kilowatt peak in a year. These are already studied and done. Our historical timeline of solar started from small scale, almost 30 years ago, 1996. This kind of small one panel system in the mostly remote places, rural places, wherever the electricity was not available. So like, this kind of trolley cart houses, the village shops, etc. Okay, so what is very amazing, this kind of small systems has over 220 megawatt of capacity, which provides 18 million people, which is the 11% of the generation. So this is small, one panel systems are massive, they are helping a lot. 11 million, 18 million people is not a matter of joke, but by only one panel systems. Okay, we call it small system, small home system, SHS. Then, like around 2010, 9 or 10, whenever the then government started some kind of movement that every houses has to have some kind of solar panel system on the rooftop. So I found that, I was that time working, collaborating with Atomic Energy Commission. So I found in their Agarga office, they had a tracking system and they had a fixed system on their rooftop for pumping, for lighting in the whole building. So this is the beginning of solar like rooftop system. So since then we have rooftop systems are somewhere, sometimes malpracticed or some kind of other, like, you know, I cannot say they could not find out the real benefits. Rooftop systems, most of them are obsolete. So recently, yes, rooftop systems, because it is NEM, net energy metering, means I do not store in my battery. I will sell it to the grid, and from at night I'll buy that from the grid. So there will be a plus minus thing. So there are big companies, like for example, in Korean 𝐒𝐻𝐸, Yangwon company, they installed 16 megawatt peak on their rooftop in Chittagong. These are the biggest rooftop system, maybe one of the biggest systems in the whole world. Then solar mini grid, okay, 100 kilowatt peak range, we call it mini grid. It is installed, first one is in Shundi, this place, Shundi, okay, 100. So mini grid needs batteries storage. So this is a little bit bulky and this is costly as well. Battery we want to eliminate the cost of the batteries because they need, after a few years we have to change or take maintenance, all those things. Then first grid connected was in 2017, I think, in Jamalpur, maybe in Jamalpur, here, yes, Jamalpur. So 3 megawatt systems in 2017 they installed, and this is a mini grid. This is a first grid connected, means they do not need any batteries. This is amazing. In fact, battery is a huge cost. Okay. Then large scale solar, which is in megawatt peak range. So in 2020, TS they call Teknaf solar. Okay. So in Teknaf here, I studied the map of Bangladesh. Where is Teknaf? Very near, just in the bordering place of the Myanmar. So they have 20 megawatt peak AC, but 28 megawatt peak DC. DC should be a little bit because of the inverter we lose some. Okay, so this is also big. This is amazing because in Bangladesh, when I was professing, no, we should have LSS. People say, where is the space? Where is the place? Show us that space. But now we are getting a lot of unused space where we can do agrivoltaics, we can do large scale solar. This is not the end. In 𝐶𝐶𝐽𝐺, this is I went there. After you cross the river Jamuna, on the right hand side, you can find 68 megawatt solar power plant by Bangladesh China Renewable Energy Company Limited, in just after the river Jamuna, bridge after the Jamuna bridge. So this is very elevated because you will see whenever there is water flood, it will not create any problem to the solar panels. It's quite elevated, quite at height. So this is the list I was telling. In Bangladesh is planning. See, there are either completed or running. 1 megawatt, 75, 200, 300, 20, 30, 100, so many in the pipeline. So by the year 2030, we are expecting 4 gigawatt of solar installation in 72 solar parks. So, but Bangladesh aims much higher. By the 2041, we are trying to have 40% renewable energy share, so which will be 10 times of current installation in the next 15 years, which is very challenging, which is also prospective. Means you can do business, you can do whatever you want, because this is the only answer to us. Okay? And as I mentioned, the green lifestyle for requirement, they need to reduce the recycling. Worldwide, we are expecting huge amount of PV waste, module waste, or electronic waste. Electronic waste is one thing, PV waste is another thing. So we will be expecting huge amount of waste, but Bangladesh is also expecting that metric tons of end-of-life solar photovoltaic modules by between these years. You can also work on recycling, like we did on sheet breakage in Chittagong. So similar kind of things we can do. How to do recycling more efficient? How to do the recycling of our own, not from, because some countries will send to you how to do the recycling of the end-of-life PV panels. So this is also research as well as a business opportunity here. Now, what is our activity in Bangladesh? I should say that I have limited knowledge about the whole things, but as far as I know, this is the lab in Chittagong University of this is the lab where I wrote the proposal for them in 2010. It was a HICCUP project, and they got 5 crore taka, and they established this laboratory where thin film solar cells can be done, whatever we can do. And Professor Mohammed Abdul Motin Bhuiya, he was my first PhD student, and now he's the VC of 𝐶𝐶𝐽𝐺, so far I heard, right? Yes, he met me, right? After becoming the VC, he met me. So he, under his guidance, under his supervision, this lab was established, and they produce PhD and masters they're producing. So they have like all lineup of the whatever equipment they need for the second generation thin film solar cells, materials as well as device. So because I'm from Chittagong, I often go there. My hometown is very near to the village is very near to the 𝐶𝐻, so I often go there, and then we do some collaboration research as well. Then BCSIR, it is the second lab I helped, in fact, from conceptualization as well as what they need, what can be done. This is in IEEE, Research Institute, I think. So they have also labs they can produce, and I was giving them some initial training, all those things, in 2017. This is the picture from 2017. This is a much higher budget, 3.5 million or 28 crore taka they got directly from ministry. Then with nanotechnology now, it becomes nanotechnology and ceramic, right? Department. Glass and ceramics they came. And on 4th of December, I'll be giving another talk, but there doesn't that much on the thin film solar cells. Professor Salam, right? He passed away during the COVID. I met him before the COVID. So they have also equipments that I gave a talk there. They have also equipments which can be used for solar cell materials. So you can do collaboration with them. They have a lot of equipments. Usually they kept it for ceramics, characterization, materials characterization. So all those things. Now, what is the prospect of PV carrier towards then? Almost 3 more slides. What is for you? For example, development of possible degradation model. You can do what? You can do from software. You can check the degradation modeling. Why? Because a huge amount of solar panels around the world, but they degrade at some percentage. You can do some. You can do some visual camera. You can start how they degrade. You can create some kind of environment, like chamber where you can give more temperature, more moisture, etc., etc. By that you can do and understand the realistic cause of the root causes of the problems, degradation under the realistic condition of Bangladesh. You can create. This is one you can do. Then also prediction modeling, because Bangladesh, we will be having a lot of LSS. LSS cannot sit for one single day. They have already promised that how much they will provide. So one panel problem may create whole shutdown. So we have to predict before it fails. So you can do some kind of, again, prediction modeling, doing some visual camera plus electrical things. But there are, of course, I may sit down with you to give more details on it. Then third one, smart mini or microgrids with AI, IoT applications, okay, management, micro or nano grid management you can do, okay. Then fourth one, smart PV recycling at affordable cost you can do. You can start breaking in one. How can recycle the materials? How can, okay? You can check one of our papers. We do, like, by crushing them, or by solvent based, or by liquid process, or by physical process. You can do. Then you can do solar cell fundamental research on various aspects with limitations, because you don't have the labs. If you have, you're lucky. But you can use the labs in BCSIR, and also 𝐏𝐻𝐻 is going to have equipment soon. You can have a joint collaboration lab. This is what we dream, that we have a centralized lab where everybody can work to do the masters. They'll get their theoretical knowledge here, but they can come to a centralized lab. Like in the USA, they have an NREL, National Renewable Energy Laboratory. So I guess there will be some, or I dream there will be a lab, centralized lab, where people can work on the fundamental things and other things. This is for what? For confidence and competence growth. Yeah, maybe our solar cell may not see the commercialization in future. We may not compete with the Chinese market, Chinese manufacturer. But what we can do, we can be more, competent, more knowledgeable, and we can lead research in China. We can lead the research in USA, in Japan. We can go for PhD. We can go for work. Okay. So this is my concluding remarks. We have seen the shift of mainstream to renewables, and solar PV is now one of the leading renewable energy resources, which can be as gigawatt peak scale, like as nuclear scale. Bangladesh's power generating landscape also are changing now. 80% of the renewable energy comes from the solar, as you saw, but we need many innovative uses of PV applications, maybe in recycling, maybe in studying the degradation process, or maybe making new things. So we must explore all forms of solar PV technologies, as huge PV installations are expected onwards for a carbon neutral future by the 2050, not only for Bangladesh, for world as well. So where is the future of PV in Bangladesh? You can see. You call it reclaimed land. Nobody uses this land. It is marshy. So you can put solar panels, 2 meter, 3 meter high poles that we saw. Already we have the examples. So you can use. Believe me or not, after coming back I was away. I was overseas for 32 years. So whenever I came back for a long time, I saw Bangladesh's population is densely populated in Dhaka and surroundings. There are huge amount of open space in Jamalpur, in Shirazganj. Wherever I go, I found that there are huge unused lands. People always concentrate in this area. So Bangladesh has a lot of lands, prospective lands for PV installations. So these are the things, in marshy lands, even rooftops. I sometimes guess you can do some study. If we can acquire all the rooftops of Dhaka or Mirpur or some of those satellite towns, how much PV can be generated? Easily. Grid connected PV can be generated. We just acquire those. Huge amount of PV may be generated from our own buildings. So we look forward to a solar in Bangladesh in the coming years. With that, I'd like to conclude my talk. Thank you so much for the.
Thank you, Professor Amin, for the wonderful talk. If you have any questions. Any questions?
Any questions in Bengali? If you want, if you feel convenient, no problem. Language is just a medium. It should not be a barrier. বাংলায়ও আমরা কথা বলতে পারবো যতটুকু পারি আমি এক্সপ্লেইন করতে পারি। যে কোনো কোশ্চেন?
কোনো কোশ্চেন?
স্যার সোলার প্যানেলস গুলো এগুলো কি জাস্ট ল্যান্ডে লাগানো যায় নাকি ওয়াটারেও আমরা এগুলা ল্যান্ড করতে পারবো?
হ্যাঁ, ওয়াটার আমি দেখিয়েছিলাম যে আমরা ফ্লোটিং সোলার বলে একটা কথা আছে। ফ্লোটিং সোলার একটা নতুন টার্ম। এখন সোলার প্যানেলগুলোর তো ভিতরে আমরা ফ্লোটিং সোলার কোথায় দিব? লেকে ওয়াটারে দিব নাকি সি ওয়াটারে দিব নাকি পন্ড ওয়াটার দিব? প্রত্যেকটা ওয়াটার ডিফারেন্ট। ওদের কর্পোরেশন থেকে কিন্তু সল্টের ইরোশন হতে পারে। ভিতরে যে আমরা সোলার প্যানেল পিছনটা খুললে দেখা যায় কি আমাদের কিছু ইলেকট্রনিক্স থাকে, ওইটা কিন্তু স্টাডি করে ওভাবে আমাদেরকে রোবাস্ট ওই ইলেকট্রনিক্সটা দিতে হবে। কাজে এটা যে কোনো জায়গায় দেওয়া যাবে। দেয়ার মাইট বি সাম ডিস্টেন্স, মানে 50 সেন্টিমিটার অ্যাবাভ দি ওয়াটার লেভেল করতে হয়। কিছু বয় দিই, আমরা বয় দিই। অনেক সময় 100% মানে কি করি আমরা পুরো প্লাস্টিক দিয়ে আমরা একটা বয় বানাই যার সাথে কোনো মানে ওয়াটারের সাথে কোনো টাচ, কোনো ইয়ে থাকবে না, ইন্টারফেস থাকবে না। আর অনেক সময় খালি থাকে, মানে সরাসরি ওয়াটারটা হয়তোবা পিছন দিকে আসতে পারে, ইয়েতে ওয়াটার ভেপোরাইজেশন হয়ে সোলার প্যানেল পিছনে গিয়ে আবার প্রিসিপিটেশন হতে পারে। ওগুলো স্টাডি করতে হয়। সিঙ্গাপুর করেছে যেটা, সেটা হচ্ছে ওয়াটারটা প্রিসিপিটেশন হতে পারে যার জন্য প্যানেলটা একটু ঠান্ডা হয়। ঠান্ডা হলে কিন্তু এটা ভালো। সিলিকন সোলার প্যানেল কিন্তু গরমে ডিটেরিয়েট করে। কাজে এটা একদিকে ওরা ভালো দিচ্ছে কারণ হচ্ছে পন্ড ওয়াটার, ওখানে বলতে কিন্তু সল্ট নেই। হ্যাঁ, তো এই জন্য এগুলি একটু স্টাডির ব্যাপার। মানে সরাসরি ডাইরেক্ট কন্ট্যাক্ট নাও দিতে পারে, আবার ডাইরেক্ট কন্ট্যাক্ট ছাড়াও দিতে পারে, সহ দিতে পারে।
সেমি ট্রান্সপারেন্ট সোলার সেল বিল্ডিং এ উইন্ডোতে ইউজ করা, এটা প্রোগ্রেসটা কেমন?
আসলে ওইটাতে
অনেক বেশি আছে ডিটেইলে
সেমি ট্রান্সপারেন্ট। হ্যাঁ, আচ্ছা, সেমি ট্রান্সপারেন্টের ম্যাটেরিয়ালগুলো সাধারণত করা হয় কি খুবই থিন, হ্যাঁ, অ্যামরফাস সিলিকন ইউজ করা হয়, বা কোনো অর্গানিক ম্যাটেরিয়াল ইউজ করা হয়, ডাইসেন্সিটাইজ সোলার। তো ওরা আসলে ইয়ের থেকেও বেশি হচ্ছে ওদের মানে কতটুকু প্রোডাকশন করবে না, সিলিকন যেটুকু প্রোডাকশন করবে তার থেকে অনেক কম, ওদের ইল্ড অনেক কম থাকে। কিন্তু আমার ক্ষতি কি? মানে আমি বললাম যে আমি একটা গ্লাস দিয়ে রাখলাম, হ্যাঁ, গ্লাসের মধ্যে। কিন্তু এখন আরো মজার ব্যাপার হচ্ছে যে সোলার প্যানেলগুলো আমরা দিচ্ছি, আমরা যেসব মানে অফিস বিল্ডিং গুলো মেনলি আমরা কাঁচে, তাই না, সব তো রোবাস্ট গ্লাস। একটা রোবাস্ট গ্লাসের 1 স্কোয়ার মিটারের যে খরচ, একটা সোলার প্যানেলের খরচ একই, এবং সোলারের এই সেই রোবাস্ট গ্লাস ইউজ করা হয়। কাজে অনেক জায়গায় পুরোপুরি যে হয়তো একটা প্যানেল দেওয়া হচ্ছে, পাশে একটা নর্মাল গ্লাস, তাহলে ডে লাইট আমরা ইউজ করতে পারছি, আবার এনার্জিও পাচ্ছি। এইটা করা মাছ বেনিফিশিয়াল দেন ওই যে সেমি ট্রান্সপারেন্ট। ওটা আমরা আমাদের
50-50 মানে একটা আমরা আসলে 50
হ্যাঁ 50 হলো ওভাবে আমরা সেমি ট্রান্সপারেন্ট এইভাবে করি, তাহলে আমার পুরো এটা অনেক কষ্ট। কিন্তু এরকম আছে মানে অপশন, ইউ হ্যাভ দ্য অপশন ইফ ইউ হ্যাভ দ্য
সেমি ট্রান্সপারেন্ট সোলার সেল। জার্মানিতে মনে হয় একটা বা দুইটা কোম্পানি মানে আর কোথাও আমি দেখতেছি না প্রসপেক্টসটা না।
কারণ এর চেয়ে বলা হয় যে সিলিকন, কেন সিলিকন এখনো 90% মার্কেট শেয়ার সিলিকনের, বাকিটা হচ্ছে যে থিন ফিল্ম। পারবস্কাইট এখন আসেনি, আসবে করছে, এরকম অনেক কিছু হচ্ছে। কিন্তু সিলিকনকে আমরা কেউ ডিনাই করতে পারছি না, কারণ সংখ্যন হচ্ছে বালি থেকে আমরা সিলিকন এক্সট্রাক্ট করে সিলিকনকে আমরা ওই ভিএলএস এ বানানোর মতো পিউরিটি আমাকে দিতে হয় না। 99.99% মানে আমরা 4N বলি আর কি, 4N মানে ভিএলএস এ যারা করবে তারা কিন্তু জানতে হবে না। 11N মানে কি 99.9 পিউরিটি, 11N পিউরিটি। আর সোলার সেলের জন্য লাগে মাত্র 4N পিউরিটি বা 5N পিউরিটি সিলিকন ওয়েফার। তো সিলিকন এত কম খরচে আমি যদি বানিয়ে ফেলতে পারি, আমার অত কষ্ট করে যে হ্যাঁ ওটা যদি অ্যাস্থেটিক করা হয়, যেমন যেভাবে কালারফুল করা হয় যে দেখার জন্য যে ওটা করতে পারে, দ্যাট প্রডিউসেস। বাট ওভার দ্য পিরিয়ড অফ 1 year মেবি যদি আমি একটা গ্লাসে উইন্ডোজ সিলিকন লাগাম আর একটা করলাম না, এই কনসেপ্টে এই কষ্ট অনেক বেশি আমাকে এনার্জি দিবে দেন ওই যে সেমি ট্রান্সফার।
একটা জিনিস ধর বাংলাদেশে তো সোলার হোম সিস্টেমে তো সেটা অনেক কাজ করে দেখছেন, বাট এখন তো দেখা যাচ্ছে যে আবার লাইনই চলে গেছে, সেই জন্য সোলার হোম সিস্টেম কিন্তু আগের মতো পপুলার না।
সোলার হোম সিস্টেম হচ্ছে সব ছিল আরবান এরিয়াতে।
হ্যাঁ, এখন তো ওইসব জায়গা তো আগে ভোলাতে ইয়ে ছিল, কিন্তু এখন তো ভোলাতে লাইন চলে যাচ্ছে, ওখানে পাওয়ার প্ল্যান্ট হচ্ছে।
লাইন চলে গেলেও কিন্তু লাইনে তো কারণ নেই, আমরা শতভাগ বিদ্যুৎ মানে শতভাগ লাইন আছে।
সোলার হোম সিস্টেমের ডিসঅ্যাডভান্টেজ নেই। আমি যেটা বলতে সোলার হোম সিস্টেম থাকলেও যদি বেসিক্যালি যদি আমরা প্রমোট করি যে গ্রিড কানেক্টেড, দ্যাট ইজ ওইটা বেশি বেনিফিটেড হবে না।
আমার অবশ্যই গ্রিড কানেক্ট, আমার তো ব্যাটারি লাগছে না, অবশ্যই গ্রিড কানেক্টেড সবচেয়ে বেশি এখন বেনিফিশিয়াল। আমার ব্যাটারি কষ্ট পুরোপুরি আমার ইয়ে করে দিল, কিন্তু আসলে দাম তো বাড়বে। আমাকে সোলার ইলেকট্রিসিটির দাম সবচেয়ে কম, আমাকে এলসিওই নিয়ে চিন্তা করতে হবে। একটা টার্ম হচ্ছে এলসিওই, লেভেলেজ কস্ট অফ এনার্জি। ওটা যদি চিন্তা করি সোলার হচ্ছে সবচেয়ে কম। আমি লাইন থাকলেও কিন্তু আমি লাইন, ফর এক্সাম্পল আমার কিছু সামর্থ্য হলো আমি গ্রামে একটা বাসা করবো, আমি ফার্স্ট অফ অল আমি বাংলাদেশের পার্সপেক্টিভে আমি চিন্তা করবো যে আমি কোনো লাইন নেবো না।
স্টিল আমরা কিন্তু মনে করি যে ওয়াটার বেস যেগুলো সেগুলো 2-3 টাকা পার ইউনিট। ওয়াটার বেস হাইড্রোলিক যেটা বাংলাদেশে
আমার কাছে 2-3 টাকা করে আসতেছে না।
না না, আমরা তো কিনতেছি আর 60 টাকা করে, কিন্তু
সাবসিডাইজ বলে আমরা ওটা পাচ্ছি, তাই না?
তার মধ্যে হচ্ছে যে সোলারের 15 থেকে 20 এর মধ্যে পড়ে।
নো 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 রং। ইন্ডিয়াতে কত 3 সেন্ট,
না বাংলাদেশে গভর্নমেন্ট যেটা
কিনে সেটা তো ডিফারেন্ট।
আমি সেটা বলতেছি,
সেটা বাংলাদেশে প্লিজ ডু নট পুট বাংলাদেশ ইন এনি কাইন্ড অফ এক্সাম্পল।
ওই যে টেকনোলজিটা দেখা যায় না, গভর্নমেন্ট আমি দেখছি এটা ওরা 15 থেকে 20 এর মধ্যে হচ্ছে রেট। হ্যাঁ, আমরা সে কিনতেছে কেন কিনতেছে এটা সেটা প্রাইস তো ভেরিয়েশন আমি জানি যে আমরা যখন ইম্পোর্ট করছি সেটা এত দাম কেন, সেটা বাংলাদেশে। কিন্তু ওয়ার্ল্ড ওয়াইড আমরা দেখি আর ওভারঅল যে ওয়ার্ল্ড মার্কেটে কত করে ভ্যালু, এটা যদি 3 সেন্ট 5 সেন্ট মানে 5 টাকা 9 টাকা এরকম, 8 টাকা 9 টাকা, কিন্তু মানে ওয়ার্ল্ডে সারা ওয়ার্ল্ডে যদি আমি এভারেজ করি 8-9 টাকা, ইন্ডিয়াতে 3 টাকা 4 টাকা। হ্যাঁ, তাহলে আমার বাংলাদেশ তো ডিফারেন্ট কেস। বাংলাদেশে এটা আমরা বলতে পারি, কিন্তু কেন হয়েছে আমরা জানি না, রাইট? সেটা তো দেখবেন 15 থেকে 20 এর মধ্যে সব আছে। এখন গভর্নমেন্ট বাইং প্রাইসই হচ্ছে 15 সেন্ট থেকে 20 সেন্ট। আমি 100 টাকা ডলার ধরলেও 15-20 টাকা করতেছে। না না, এটা চুক্তি করে ফেলছে।
এই যে চুক্তিটা, এইটাই কথা। আমি কিছু দেখি পেপারটা আমাকে করতে পাঠায়, রিভিউ করতে পাঠায়, মানে কিছু আছে যারা ফটোনিক্স নিয়ে কাজ করতে এক সময় তার চেষ্টা কিন্তু ফ্যাব্রিকেশন ইজ ভেরি ভেরি, যারা ফ্যাব্রিকেশন নলেজ রাখে, যারা তোমার স্যার যে কি যে কষ্ট, মানে একটা এমবি একটা এক্সপেরিমেন্ট করতে হয়তো 2 দিনও লাগতে পারে। যে আমরা বলতেছি যে ঠিক আছে আমরা উপর একটা পিরামিড শেপ, মানে কনসেপ্ট হচ্ছে একটা সার্ফেসের উপর আমি কি করবো বল শেপ, ন্যানো বলের মতো দিব। ইট ইজ ভেরি ভেরি টাফ, ইট উইল বি টাফ এন্ড ইট উইল বি হিউজলি এক্সপেন্সিভ। রাদার ওটা না করে আমরা অন্য একটা প্রসেসে আমরা এফিশিয়েন্সি বাড়াতে পারি। হ্যাঁ, ইট শুড বি there will be some studies, of course people দেখবে এরকম স্টাডি করবে যে মানে ওরা করে কি ফটোনিক্সের বিভিন্ন কনসেপ্ট, যে স্ট্রাকচার সারফেসের উপর স্ট্রাকচার কি করছে, নতুন পিরামিড শেপ করছে অন্যরকম করে। হ্যাঁ, কিন্তু ওটা ফিজিক্যালি তৈরি করা তো ফ্যাব্রিকেশন ইজ রিয়েলি দোজ হু হ্যাভ দ্য নলেজ অফ ফ্যাব্রিকেশন। ফার্স্ট যখন দেখবে পেপার সিমুলেশন বেসড অনেকে এটাকে নিয়ে সিম্পলি রিজেক্ট করে, যেটার কোনো প্র্যাকটিক্যালিটি নেই, সে হয়তো এই সাইডটা জানে না। হ্যাঁ, তুমি যেটা বলছো যে বেটা ম্যাটেরিয়াল অনেক ম্যাটেরিয়াল আছে, কিন্তু তোমাকে বুঝতে হবে যে মানে পিএন জাংশন আমরা যেটা করি সেটা মেইনলি হচ্ছে পিএন জাংশন, এবং পিএন জাংশনে আবার কিছু কিছু আছে তোমার ক্রিস্টালাইন হতে হবে, কিছু কিছু পলিক্রিস্টাল মেটেরিয়াল ভালো। কিন্তু এটা আসলে তুমি যদি ম্যাট্রিক্সের যতই তুমি সোলার সেলের দিকে যতই করবো তাদের দেখবে কি যে অনেক সময় পিওর সিলিকনের চেয়েও অন্য একটা ম্যাটেরিয়াল তোমাকে ভালো দিতে পারে। একটু নলেজটা যখন ডিপ হয় তখন আমরা বুঝি যে না এরা যে রিসার্চ করছে, এই যে নতুন নতুন ম্যাটেরিয়াল করছে, আসলে এদের অপটিক্যাল, আমি 3টা জিনিস বলেছিলাম প্রত্যেকটাতে, স্ট্রাকচারাল, অপটিক্যাল এন্ড ইলেকট্রিক্যাল প্রপার্টি। অপটিক্যাল প্রপার্টি 100 হতে পারে, ইলেকট্রিক্যাল প্রপার্টি আর স্ট্রাকচারাল প্রপার্টি নট ফিজিবল স্ট্রাকচারাল প্রপার্টি টু বি ইন্টিগ্রেটেড উইথ দ্য সিস্টেম, অ্যান্ড ইলেকট্রিক্যালি এটা আউটপুট ভালো না হতে পারে। ওরা সবসময় অপটিক্যাল নিয়ে চিন্তা করে। একটা সোলার সেল কিন্তু আমার 3টা জিনিস চিন্তা করতে হবে, অপটিক্যাল, ফার্স্ট অফ ফিজিক্যাল, অপটিক্যাল অ্যান্ড ইলেকট্রিক্যাল। সেজন্য যারা ওই জিনিস নিয়ে রিসার্চ করে তারা শুধু অপটিক্যাল নিয়ে বলে যে হ্যাঁ অপটিক্যাল আমার এত পার্সেন্ট অ্যাবজর্পশন বাড়িয়েছি, কিন্তু এই অ্যাবজর্পশন বাড়ানোর পর কিন্তু যে ইলেকট্রনগুলি কি ওই কন্ডাকশন ব্যান্ডে উঠে কি যাবে, বের হতে পারবে, নাকি তার আগে সে রিকম্বিনেশন হয়ে যাবে, এটাতে বিশাল একটা, ওই জন্য ওই পুরো নলেজটা থাকলে তখন আমরা বুঝতে পারি কি ধরনের সিমুলেশন করা উচিত। অনেকে অনেক সিমুলেশন করে, আমি বাংলাদেশে অনেক IEEE কনফারেন্সে দেখি, মানে শুধু অপটনিক মানে এই ফটোনিক্সের ব্যাকগ্রাউন্ডে, কিন্তু ওরা সোলার সেল এফিসিয়েন্সি বাড়ানোর জন্য প্রপোজ করে, কিন্তু ওদের ওই জিনিসটা হয়তো যে পিএম জাংশনের ব্যাপারটা হয়তো অতটুকু ওরা ভাবে না, ওরা অ্যাকচুয়ালি একভাবে চিন্তা করে। তখন এটা মানে বাংলাদেশের জন্য হ্যাঁ বাংলাদেশের পার্সপেক্টিভ আমরা অনেক সময় এটাকে অ্যালাউ করে দিই, হ্যাঁ ঠিক আছে নতুন কনসেপ্ট, বাট এটা ফিজিবিলিটি টাফ।
আমরা যে ওয়াটার বেস যে সোর্সগুলোর কথা বলতেছিলাম, স্যার এগুলো কি কমপ্লিটলি ফ্লোটিং করা পসিবল? লাইক আমাদের দেশে তো বন্যার সময় মাঝে মাঝে ওয়াটার লেভেল রাইজ হয়ে যায়, আবার অনেক সময় লো হয়ে যায়, তো এটাকে কি সবসময় ফ্লোটিং রাখা পসিবল এক জায়গাতে? কারণ এটা করলে তো পানির কাছে থাকবে আর
না না, আমি একটু আগে ওকে কথা বলেছিলাম, যদি আমি বয় যেটা বয়, আমরা বয়া বলি না বাংলায়, বয় বলি, BOEY, বয় যেটা যে ফ্লোটিং সাপোর্টটা থাকবে সেটাকে চাইলে পুরোপুরি শাটডাউন করে দিতে পারবে। সোলার মানে পুরো একটা প্লাস্টিকের একটা এরকম কি বলি একটা স্ল্যাব, ভিতরে বাতাস, প্লাস্টিকের স্ল্যাবের উপরেও আমি সোলার প্যানেল দিয়ে ফ্লোটিং করে দিতে পারি।
আমি জাস্ট সিম্পল ড্রামের উপরে বসিয়ে দিই,
ড্রামের উপর বসাতে পারি, না একটু দূরে হলে তো হচ্ছে আবার পানিটা এটা আঁচটা লাগবে, হ্যাঁ দূরে থাকা আঁচটা লাগবে। আমরা মানে এখন দুইটা জিনিস আছে, একটা হচ্ছে কি যে সিঙ্গাপুরে আমি বলি ওরা চায় যে পানিটা যাতে এভাপোরেট না করছে, সেজন্য ওরা আবার মানে কি বলবো পাইপ দিয়ে কত স্ট্রাকচার করছে, তারপর সোলার প্যানেল, তাহলে তাদের পুরো খরচটা কমে গেল, প্লাস্টিক পুরোটা দিতে হলো না। আবার কিছু কিছু আমেরিকার কিছু কিছু জায়গায় দেখলাম পুরোটা বয় আর কি, মানে প্লাস্টিকের স্ল্যাব, ভিতরে বাতাস, প্লাস্টিকের একটা প্লাস্টিক আপনার ফ্লোটিং আছে না স্ল্যাব, তার উপরে সোলার প্যানেল করে দিচ্ছে। দুটোই হতে পারে, ভাসবে, তাহলে বন্যার সময় ভাসবে, আমার তো টাচ করছে না করছে পানির সাথে, রাইট? একদম ওইভাবে পাওয়াই যায়। এখন ওই ধরনের সেট আপ কত ডিগ্রি অ্যাঙ্গেল সে ইয়ে করে থাকবে, ওরকম বয় পাওয়া যায়, মানে সোলার প্যানেল যখন আমরা যখন সেট করি তখন একটা অ্যাঙ্গেলের ব্যাপারটা আছে, রাইট? আমার ল্যাটিটিউড হিসেবে আমাদের কত ডিগ্রি অ্যাঙ্গেল রাখলে আমরা বেশি সূর্যালোক পাবি, সেরকম একটা ব্যাপার আছে, রাইট? সেই জন্য আমরা করি কি ওইখানে করছি কি ওই বয়টা বানাচ্ছি, বয় মানে কি ভাসমান যে ফ্লোটিং স্ট্রাকচারটা বানাচ্ছে, সেই ফ্লোটিং স্ট্রাকচার থেকে ওভাবে বানাচ্ছে যে আমরা জাস্ট বসালেই সোলার প্যানেল বসবে। Any other question?
স্যার আপনি একটা লিস্ট দেখিয়েছিলেন সিমুলেশন সফটওয়্যার, মানে
আচ্ছা।
সিমুলেশন
Simulation.
সফটওয়্যার, স্যার এগুলোর ভিতরে মানে কোনগুলো প্রাইমারিলি বেশি ইউজ হয় বা কেউ যদি স্টার্ট করে নতুন করে কোনটা?
AMS, SCAPS, AMS, SCAPS, AMPS আর SCAPS এই দুইটা বেশি চলে। আর সেটা হচ্ছে ডিভাইসের জন্য, ডিভাইসের জন্য তো এই দুটাই বেশি। আর কেউ যদি সিলিকন করতে চায় তাহলে ফোর্স সেট করি আমরা, সিলিকনের জন্য এক ধরনের, থিন ফিল্মের জন্য এক ধরনের, হ্যাঁ, তারপরে এক্সোটিক ম্যাটেরিয়াল যেগুলো আসছে সেগুলোর জন্য হয়তো আর একটু। আমরা অবশ্যই ম্যাক্সিমাম দেখি কি AMS, SCAPS, এ ফোর্স সেট করি, এ ফোর্স সেট, এ ফোর, আচ্ছা এই দুটো পারি।
স্যার এই সোলার এনার্জির সবথেকে বড় ড্রব্যাক হচ্ছে স্যার যে ব্যাটারি স্টোরেজ, জি স্যার এটা নিয়ে কোনো স্যার ডেভেলপমেন্ট আছে কিছু?
ব্যাটারি স্টোরেজটা যাতে না হয় সেজন্যই তো আমরা যে গ্রিড কানেক্টেড, মানে গ্রিডই হচ্ছে আমাদের ব্যাটারি। যদি আমরা ডেভেলপ কান্ট্রি হতাম, যদি আমাদের সবকিছু ঠিক থাকতো তাহলে গ্রিড হতো আমাদের ব্যাটারি। বিকজ মালয়েশিয়াতে কিন্তু আমরা এখন, আমি নিজের বাসাতে সোলার প্যানেল লাগিয়েছিলাম 5 কিলোওয়াটের, আমার চমৎকার করে আমার বিল জিরো, এবং আমি ওই 5 লাখ টাকা সেটা আমি দিব 3 বছরে, প্রতি মাসে আমার প্রায় 12,000 টাকা বিল আসবে, সেটা প্রতি বছর আমার যে ডাউন পেমেন্টের সাথে ডাউন পেমেন্ট ইনস্টলমেন্ট ইএমআই যিনি বলে ওটা দিয়ে আমার শুধু এইভাবে আমার 3 বছর পরে আমি একটা ফ্রি একটা মালিক হয়ে যাচ্ছে একটা সোলার সিস্টেম। কান্ট্রি হ্যাজ রুলস পলিসিস অ্যান্ড ইমপ্লিমেন্টেশন। পলিসি যদি আমাকে হেল্প না করে, টেকনোলজি যেখানে কাজ করে না সেখানে পলিসি দিয়ে হেল্প করতে হবে। টেকনোলজি যেখানে লিমিটেশন আছে, ব্যাটারি লিমিটেশন, ব্যাটারি ইজ দ্য ওল্ডেস্ট টেকনোলজি, রাইট? এটা হচ্ছে একটা ড্রাম, আসলে পানি ড্রাম, মানে চার্জের ড্রাম। কিন্তু এইটা তো আমি মানে এখানের মধ্যে হ্যাঁ এখন লেটেস্ট ব্যাটারি প্রযুক্তি আপনার কি আসছে, লিথিয়াম ব্যাটারি, লিথিয়াম আয়ন ব্যাটারি। আচ্ছা, আমি যাতে অ্যামস এর দুইটা ভার্সন আছে, অ্যামস 1 আর ডাব্লিউ এটা, এই দুইটাই কাজ করে খুব ভালো সব জায়গায়। আর একটা লিখে সত্যি ইয়ের নামটা লিখে দিই, ওটা স্ক্যাপস। ওটা হচ্ছে পিসি 1 ডিও আছে, হ্যাঁ এটাও আছে। মেইনলি এটা এফোর্টসেট অ্যামস এইটা এইগুলি হচ্ছে, আর এগুলো একটু বেশি আর কি, বেশি কি কত লাগবে না, এইগুলি নিয়ে কাজ করলে মোটামুটি অনেক আইডিয়া পাওয়া যায়।
অপটিমাইজেশনের আমাদের আগে স্লাইড অপটিমাইজেশনের ডেভেলপমেন্ট দেখেছিলাম, এটার জন্য আমাদের সিস্টেমের জন্য অপটিমাইজেশনের জন্য হোমার এবং পিভিসি দিয়ে তারা
পিভিসি হচ্ছে প্রফেশনাল হয়ে গেছে। টুইটার কিন্তু অনেক, আমি 2004-5 থেকে আমি ইউজ করি এগুলি, তখন ফ্রি ছিল, তখন আপনারা স্টার্ট করেছে ফ্রি ইউজ করা, আমরা তখন এগুলো দিয়ে শেখাতাম।
আমাদের এখানে হোমার ইউজ করে
না, পিভিসি প্রফেশনাল,
না, আমরা হোমার ইউজ করি।
হোমার তো মানে ই করে, হোমার তো আসলে রিনিউয়েবল এনার্জি, নট সোলার। পিভিসি হচ্ছে সোলার, হোমার কিন্তু রিনিউয়েবল এনার্জি, অনেক কিছু অ্যাড করে। হ্যাঁ, আর পিভিসি হচ্ছে একদম শুধু পিভির জন্য। এটা একটা এখন একটা প্রফেশনাল সফটওয়্যার হয়ে গেছে, যারা পিভি প্ল্যান করে তারা এটা দিয়ে চেক করে। আর বাসার জন্য, বাসাবাড়ির জন্য পিভি ওয়াটস, আমি আমার বাসার ছাদে লাগাবো, কত কিলোওয়াট আসবে, কত খরচ হবে, এটার জন্য পিভি ওয়াটস, এটা অনলাইন বেসড।
স্যার আমরা যে সোলার প্যানেলগুলো ক্রিয়েট করি সেগুলো রেক্ট্যাঙ্গেল শেপে, তাই না? তো এটা তো আমার মনে করেন যে হিউজ এরিয়া নিচ্ছে, কিন্তু আমি যদি এটাকে পেন্ট করতে পারি বা প্যারাবোলিক শেপে করতে পারি, তাহলে যে ল্যান্ডের যে প্রবলেম এটাকে সলভ করা যায় না? অথবা শুধুমাত্র কেন রেক্ট্যাঙ্গেল শেপেই হওয়া লাগে?
ইকোনমি বলে একটা জিনিস আছে, মানে সবসময় যে ইকোনমিক কোনটা, হ্যাঁ ইকোনমিক হচ্ছে মানে গ্লাস খুব কম দাম করতে, গ্লাস ফ্লোর গ্লাস বা যে গ্লাসগুলো সাধারণত স্ল্যাব বেসড হয়, তাই না? আর একটা ঠিক ওয়েফার হচ্ছে কি আমাদের 200 মাইক্রনের মতো। গ্লাসেরই মেইন ওয়েট, আমাদের সোলার প্যানেল ওয়েট কোথায়? মেইনলি গ্লাস, এখানে অ্যালুমিনিয়াম ফ্রেমের ওয়েটও কম, ওয়েফারের ওয়েটও কম, শুধু ওয়েটটা হচ্ছে পুরো গ্লাস। আমাদের গ্লাস এত বর্ণনা করেছি কারণ আমরা গ্লাস অনেক সস্তা, একটাতে আমি 500-600, এখন 600 পেতে পারি, 600 ওয়াট পাচ্ছি। আমি যদি বলি এখন গোল শেপ যেগুলো ট্রান্সপোর্ট করা ওভারঅল, মানে একটা জায়গা থেকে তৈরি হবে, তৈরি করে ট্রান্সপোর্ট করবে, এই সাপ্লাই চেইনটা অনেক কস্টলি হয়ে যাবে। আর আমি তো বিভিন্ন শেপ, আমার তো রাউন্ড শেপ যেটা হচ্ছে, হ্যাঁ ফ্লেক্সিবল সোলার প্যানেলস আছে কিন্তু এখন, কিন্তু ওটা ওই রিজিড সোলার সেল হচ্ছে, ওদের এফিসিয়েন্সি কম হবে, ওদের রোবাস্টনেস কম হবে, ওরা ভেঙে যেতে পারে, এটা ফ্রেজাইলিটি বেশি হবে, এইসব দিক দিয়ে ওরা একটু মানে নর্মাল যে রিজিডটা আছে এটা হচ্ছে আছে, কিন্তু এটা নাই যে সেটা, কিন্তু এরা কম দিবে, ওদের ওয়ারেন্টি কম থাকবে। ওরা তো গ্লাস
এই ধরনের শেপ যদি হয় তাহলে কিন্তু ইরেডিয়েন্সটা একটা ইস্যু আছে।
ইরেডিয়েন্স মানে আমি যদি মনে করি মানে ওটা, হ্যাঁ ওটা যদি এরকম করে করা হয় সকাল থেকে রাত পর্যন্ত, তো সূর্য পূর্ব থেকে পশ্চিমে যাবে, কোনো না কোনোভাবে এটাও ম্যানেজ করা যেতে পারে। মানে আমি কার্ভেচারটা অত করলাম না, আমি একটা নির্দিষ্ট কাজ করলাম। তুমি বলছো একটু ফ্লেক্সিবিলিটি করে একেবারে থাম, মানে এখানে বড় পিলার আছে কেন আমরা করি না, আছে নাই যে তা না, কিন্তু ওগুলার মানে যেটা হচ্ছে সোলার এখনো আমার ফার্স্ট হচ্ছে আমার বিদ্যুৎ সমস্যার সমাধান করা, ওইটা আসবে নেক্সট স্টেজ। যখন বিদ্যুৎ সমস্যার সমাধান হবে তখন আমি চিন্তা করবো আর একটু বেশি কনভিনিয়েন্স, এখানে একটা সোলার করি, ওটা সোলার করি, এখানে একটু কার্ভ আছে এটা সোলার করি। যখন আমার আসল মানে রিয়েল এটা মিটিগেশন হয়ে যাবে তখন হয়তো বা আরো ড্রাস্টিক একটা আসবে, নাই যে তা না আছে, আমাদের কাছে ছিল কিন্তু আমরা ভালো ইয়ে পাই না। মানে ওটা হয়তো পাথর পড়লে, কারণ ওটার জন্য ওরকম গ্লাস যেটা আছে ফ্লেক্সিবল গ্লাস নিয়ে আমরা কাজ করেছি আসলে। ফ্লেক্সিবল যে গ্লাসটা 100 মাইক্রন থিন, কিন্তু এটা এই 100 মাইক্রনটা শিলাবৃষ্টি পড়লে কিন্তু ভেঙে যেতে পারে, কিন্তু ওইগুলো কিন্তু শিলাবৃষ্টি পড়লেও অনেক সময় বেঁচে যেতে পারে, যেগুলো এখন ভিজিট।
আমার মনে হয় যে আর কোন কোয়েশ্চেন না থাকলে লেটস থ্যাংক দ্য স্পিকার। আমাদের ছোট টোকেন অফ অ্যাপ্রিসিয়েশন আছে, আমি